Wait, so it's like we do this and then
Yeah, then you put it together. Okay, 3-7B. So yesterday we did equations. What's an equation?
equal.
It has an equal sign, right? Today we're doing essentially the same thing, but with inequalities. And so this has an extra step to it because your inequality is going to change, okay? So here are the two little pieces that you need to be aware of. There are and problems and there are or problems, just like we did with equations with absolute value, okay? There are and there are or. Here's how you're going to think of it. When it's something like this, okay, x is less than or equal to, we think of it this way, that less than. So if it's less than, it's an and problem, okay? That means we're shading this way, right? And you shade inside. So if you want to make just a little graph to represent that, your less than would be looking like that when you graphed it. Greater, that's an or problem. So that's going to look more like this. Remember, the oars on a boat go out of the boat. Okay, greater and less than. So just something for you to keep in mind so you can help remember what your graph should look like. Okay. Key to what we're doing today, though, is these steps. Okay. To solve absolute value inequalities. So these are not equations anymore. These are inequalities now. So you're going to have less than or equal to, greater than or equal to, less than, and greater than. Okay. You still have to isolate the absolute value. That's always going to be your first step when there is absolute value around. How many answers are you going to get today? 2. Whenever there's absolute value, doesn't matter the problem, you will get 2 answers. The only time you don't is if you get 0 for both of them, then your answer will be 0 and you'll get 1. But that's the only time you would ever get 1 answer with absolute value, okay? Your second step in solving, once you have isolated, and most of them today will be isolated for you already. I'm going to show you one where you have to do a little bit of isolating. Most of them you're going to pick up right here. So you're going to write 2 inequalities. Just like yesterday, once we isolated, we wrote 2 equations, right? One was positive, one was negative. Today you're doing the same thing. You'll have one positive and one negative. However, now you have a symbol that goes with it. Less than, greater than, less than or equal to, greater than or equal to. Today when you write your 2, the second one that you write just flips that symbol. So if it was greater than or equal to, it's going to become less than or equal to. If it was greater than, it's going to become less than. If it was less than or equal to, it's going to become greater than or equal to. Okay? So you do 2 things. One, you write identical to the original. Just ditch the absolute value bars. That's exactly how we did it yesterday. The second one, you need to flip the symbol and change the sign positive to negative, okay? So we're going to walk through a couple of these just to make sure we're getting it. These first 2 are greater, right? Greater than. Here's what I mean by that. If your problem looks like this, okay? Absolute value of 8n is greater than or equal to 24. This is going to be an or problem, right? Greater. That means when you graph it, you're going this way. You're going away from each other, okay? Your first step is to isolate the absolute value. Is absolute value by itself? Yeah. Yes, so it's already isolated for you. So then step 2, okay, we're here, is to write 2 inequalities. One of the inequalities is exactly this. You just take the bars away. 8n is greater than or equal to 24. The other inequality, here's where your new step comes in. Yes, you're going to make it negative like we did before, but now you also need to flip the symbol. So your second one is going to be 8n is what? Less than or equal to what? Negative 24. So still do the negative, but also flip. Okay? And then you just solve both of those. And you know how to solve both of those. What do? Divide. So you're going to divide by 8 here. And you get n is greater than or equal to 3. Okay? Or, because this is an or problem, divide by 8 here. And you get n is less than or equal to negative 3. Okay? Any questions on how you solve that before I graph it? You good? We're going to do another one. Okay. So here's the deal. When you graph this, you're going to write two numbers. What are those two numbers going to be? 3 and -3, right? Your two answers. So I'm going to put a 3. Remember, 3 is going to be on the right. -3 will be on the left because we're working on a number line. 0's in the middle there. Okay. Is this open or closed dots? Closed dots because you have the bar, right? Okay. Carly, you okay? Yeah. Okay. So you're going to do a solid dot at -3 and a solid dot at +3. Okay. Now here's the thing. Because we know it's an or problem, you should know what direction your arrows are going right now. But if you forget, if you don't remember the greater part of it, just graph it, right? If n is greater than or equal to 3, at 3, we need to go greater than that. Okay. If n is less than or equal to -3, we would go this way with it. Okay. So my graph is going to look like that. Does that make sense? Okay, let's do another one. Step 1, you need to isolate. It is. Okay. So step 2 is to do what? Two inequalities. Remember, you will always get two answers. Always. Okay. Two answers. So what are my two inequalities going to look like? What's my first one? Right, so your first one is exactly how you see it. You just take the absolute value bars away, okay? My second one, 2x plus 4, right, so you have to flip your symbol. Now it's less than or equal to, and what? -5, okay? So flip it and change the sign. Is this flip it and rip it? No. Mr. Samuelson says flip it and rip it, but that's for a different one. Because you don't want to rip the negative away. You want to put the negative in. What does he say with this one? Shoot, I can't remember. And I can't ask him because he's not here today. Okay, anyway. So you have these two inequalities, and now you solve them, okay? Now, notice the difference between these. That one you just had to divide by something to solve. This one you have 2 steps to do. Don't try to do these 2 steps where you subtract the 4 and divide before you flip and change the sign. You need to flip and change the sign once you're isolated, and then you can solve. So to solve this first one, what do I do?
Subtract 4.
Take away 4. So I get 2x is greater than or equal to 1, and then what? Divide by 2. What if I was dividing by a -2 right now? If I was dividing by a -2, I'd have to flip my sign again, right? When you divide by a negative, you flip, okay? So this comes out to x is greater than or equal to 1/2. Okay? Then we're going to do it over here. Take away 4. So I get 2x is less than or equal to -9. And then divide by 2. So x is less than or equal to -9 over 2, or you can call it -4.5 if you like the decimal better. Okay. I would put them both as either decimals or both as fractions, but that's up to you. So I'm just going to call this -4.5 over here. But -4.5 is fine. And then 1/2 is going to be over here somewhere. Okay. Are these open or closed dots?
Close.
They're closed. Okay. And look at your symbol. Something is greater. That's an or problem. So your graph is going to go out like the oars of a boat. But like I said before, if you don't remember greater, less than, just graph what you know. X is greater than or equal to 1/2. That would look like this. X is less than or equal to -4.5. That would look like that. Okay? Questions on any of that? Okay, so those are the greater problems. Now we're going to do a few of the less than problems. God bless you. Okay, so this is going to be and. How do you graph and?
Well.
Like this, right? You want them to meet in the middle. Did you guys ever watch Bewitched?
What's that?
She was that witch. She would wiggle her nose. She'd go. I don't know. I can't do it. But then whenever she would like touch her fingers together, it would like freeze time.
Oh, I could do it like with.
It's very old school. No, you gotta wiggle it, not scrunch it. You gotta like move. She could like move it. I don't know how she did it. Anyway, okay. So if we're solving this, okay, less than, we're gonna graph like this, but you still have to solve it the same way as we did before. So isolate. What do we gotta do to isolate?
X minus 9. It's already isolated.
It's isolated, right? So you don't have to do anything to isolate. What's your second step?
Put down the bar and basically
Two inequalities. Okay, so this is going to be x minus 9 is what?
greater than or
Less than or equal to
12.
12, right? Write it exactly how you see it without the bars. What's your second inequality going to be? Right. Flip it and make it negative. Okay? Now you can solve both of them. So we're going to add 9 and add 9. So it's x is less than or equal to 21. And, this is an and problem, add 9 over here. What's negative 12 plus 9? No.
No, because
Negative 12 plus 9. Negative 3. Okay? Do you remember how you're allowed to write and answers? You don't have to do this, but you could write this as the lower number and the higher number as one thing, right? So I don't care which of these you do. Either you do this or you do this, okay? Take your pick. Don't do both. You don't need both.
And then you just
Okay, so you'll have a negative 3, a positive 21. Are these open or closed?
open. No, close.
When is it open?
When there's no line.
No line, okay? So these are closed. And then where are we shading?
Inside.
Between, right? These are and problems. So the overlap would be right here. Okay? Yeah.
So you see how you did negative 3 is blah blah, and then you did 21 after. What if we did 21 first?
You can't do that because you always want the less thans. I mean, technically this is true also if you flipped it to greater than. But then when you go to graph that, it's really weird because then you flip it again. So I would not do this. This is wrong. If you left it like that with less thans, that's not true. So I would say always put the smaller one first and always do less thans. Okay, example 4, and this one has one slight change to it. What do you do first? You gotta divide. Right, you need to isolate. So to isolate here, we're gonna divide by 2. Meleon, do you see, this is multiplication. This is one you were asking me about, right? This is 2 times the parentheses. So this is division. So we would divide by 2, and we would get absolute value of x minus 9 is less than or equal to 6. Okay, so first we isolated. Now we can write what? How many inequalities? Your 2 inequalities. So it's going to be x minus 9 is less than or equal to 6, right? Just take the bars away. What's the second one going to look like?
X minus 9 is greater than 6.
Flip it and make it negative. Okay? So when we solve this, add 9 here, add 9 here, we get x is less than or equal to 15. Okay? This one, add 9, we get x is greater than or equal to 3. Okay? So if you want, this is and, right? What? If you want to rewrite it, what's the smaller number? 3. So 3 should go on the left, and then always less thans. Okay, so if you want to rewrite it, it looks like that. If you don't want to rewrite it, then just leave it like this and put an and in between. So you're going to put at 3 and 15, open or closed dots? Closed dots. I should have done some with open, huh? And then where will you shade? Inside, because it's and, right? And if you need to just shade them separately, greater than 3 would go this way, Less than 15 would go this way, so your overlap is in between.
I'm confused.
On what?
I don't know. Wait, you can, you can explain all this again?
No. You need to pay attention and stop interacting with people around you, and then you will understand. I promise. Because you're a very bright young man. You just get a little distracted by other things. So.